Hi, my dear student. Myself, Dr. Dhampal Singh, HOD of the CSE department and the Associate Professor of the CSE department, JS College of Engineering. Your subject name is the Formal Language and Automata Theory. And now we are going for the second lecture of this one. As you know that prerequisite of your subject is digital logic, computer organization, and computer fundamental. This subject will be required to you to get knowledge about your automata there. And these are the course outcomes. Means after learning this course, what you are able to do. As I already mentioned, you can get the basic knowledge about your machine outputs. You are able to know that what is the Turing machine is. You are also able to know that how we can design the Turing machine and get knowledge about the power and limitation of the computer. These are the mapping of your course with the program outcomes. And these are the course contents. As you can see that fundamental in first part, then module 2 finite automata with output is there, then regular languages are there, grammar formalization and Turing machine. So this is your module 1. Right now we are in module 1. So in this part we are going to know that how we can go for the conversion. If you see that this part conversion we are going to learn. Okay. Conversion of NDFA to DFA. So before that, as I already discussed what is the deterministic finite automata and what is the non-deterministic finite automata. So student, can you tell me what is the NDFA or DFA? Think about it. Then you can go for the next part of the lecture there. Okay. So I'm giving some time to you. Okay, so deterministic finite automata, we know that for the same input, we can go to the only single step. But in case of the NDFA, for the same input, we can go to the more than one step. So now, if I say this figure, if I ask this figure, tell me whether this one is the NDFA or DFA. You have to check for the same input, more than one state is available or not. If it is, then I can say that it is the NDFA. If it is not, then I can say it is the DFA there. Now from the figure we can see this part Q0 taking the input A. Q0 input A, we can go to the Q0 and Q1. So what is the meaning? Here Q0 is one state and Q1 is also one state. So by taking the input A, we are going more than one state there. So according to definition of NDFA, by taking the input, if you go to the more than one state, I can say that it is the NDFA. So from the figure, sometimes they ask that if NDFA is given there, we have to find that what is the DFA for it. What is the DFA for the given NDFA there? Okay, so in this figure, we are going to learn how we can, if any NDFA is given there, if any non-deterministic finite automata is given there, how we can convert this non-deterministic finite automata into the deterministic one. Okay, you have to learn it. So be careful, because what I have seen that many students have doubt. They feel fear that how we can recognize NDFA or DFA. So don't worry, only simple logic. For the same input, if more than one state is there, it is NDFA. For the same input, single state, it is DFA. So design of this one is very easy. How we can go for the design of deterministic for the given NDFA. So first what we have to do that, you have to make the table like this. Here we can write the input A, here you can write the input B. And here we can see that this part will be there, state and input. Okay, this will be. Now starting from then, because as we know that if any arrow in a state, it is known as your initial state. If any concentric things present in your transition table, then I can say it is the final state. Sometime in form of the diagram they can ask, like suppose if I say this way, suppose so this is 1, this is 0. So if I give in this way, arrow means this is the initial state and concentric circle is the your final state is there, and these are the input there. So finite automata doing what? Already I have discussed in previous class, taking the from one state, taking the 0, we can go to the next state. But in case of transition table, we can represent the initial state by the this way and final state by this one. The first step, what you have to do that you can take the initial state, okay, Q0. Now task is that Q0 taking the A where it is going. It is going to Q0 and Q1. So I can write here in this way. Also make this one in this way because here means what? Here I can consider this one is the one state only. Okay. Now taking the B, it can go to the Q2. Now after that, when you're going for the conversion of the things in a deterministic, so you have to see that whatever the input will be there in this part, all will be present in the left hand side there. So here what I can see, that here only Q0 is present, but these two states are not present. So you can choose any one state. Suppose I have taken the Q2. Suppose you can also take the Q0. If you take the Q2, they have to check that by taking the Q2A input where we can reach null, nothing is there. So I can put a dash here, nothing is there. And taking the B, Q0, Q1, I have to write. Okay. So now this one already included here, but this one and this one not included. So what I can say that next step will be the your Q0, Q1. But problem is that Q0, Q1 not defined in this part. It is not available. It is available, but as a alone, one Q0 is available, then Q1 is available. Then how we can go for it? So it is very easy. We have to make the union of these two. How? Suppose here state Q0, Q0 taking the A where we can go. A union, we have to write that the Q0 and Q1 A. Okay. So Q0A where you can go, Q0 Q1 we have written. Okay. Union Q1A where you can go, Q0 written. Okay, so if I take the union of these two, what become? It become the Q0 and the Q1. So I can write. Okay, so you can write here. After similar thing we can do for the B. Q0B. Okay, Q0B. Where it is going? Q0B, it is going to the Q2. See here. Q0B, Q2. Q1B, suppose because I am going for the B, Q1B. Q1B, we are going for the Q1. So what state you are getting? You are getting Q1 and Q2 because you have to go for the alphabetic order something. So you can write Q1. Now after that, check this one included here. This is same, so already included, but here it is also included, but this one not included. Okay, so for the next step, we can go in this way. You can see same. What you have done here. Again, Q1, Q2, you can see that. You have to go for the combination of the input and check whether it is the what state is possible here. So from the previous figure, you can see. Okay, so from the previous figure, you can say Q1 taking the A, I can go to the Q0. Q2 taking the A null, nothing is there. So I can say I can get only the Q0 there. Okay. So now similarly we can go for the third part. Q0, Q1, sorry, Q1 and Q2 taking the B where we can go. Q1, Q0, Q1. Okay, so here I can take the union of these two. It will be the only the Q0, Q1. It will be only the Q0. So now after this we can check whether this is included. Yes, means all the element of the state of this one included in this part. If answer is yes, so we can stop here. So now you can see Q0, Q1 already there, Q2 is already here, Q0, Q1 already here, it is already here, Q1, Q2 already here, and Q0 is already here. So all are included, so I can stop here. After stopping, we can see I can consider suppose this one as a single state like A, this is B, this is C, and this one D. Similarly, I can write this is the C, so I can write here C, and Q2 is the your B, so I can write B, and this is null. Q0, Q1 is the C, so I can write C here, and Q0, Q1 again here to C, and this is the D, so retain. This is the A, retain, and this is the your D, retain. So now you can check that here for every input I am getting the single state there. You can see. So don't get confused. Your bracket means we are considering this one is the your single state here. Okay. So in this way we have to solve the problem. Means if any, so like this question, this is already one NDFA is given. Why it is NDFA? Already we know that for the same input more than one state. Okay, so this is the NDFA. Again we have to convert this one in form of the your deterministic. So already I have given the process. So we have to start from the state Q. We have to make this type of things, A or B, okay, and start from the Q0 because Q0 is the initial state. Okay. Second, I can say Q0, Q1, then Q0. You have to check Q0 already present here. I can start from Q0, Q1. Okay. You have to take the union of these two. So Q0, Q1 union is what? If I take the union of these two value, it becomes the Q0, Q1, Q2. It becomes the Q0, Q1, and Q2. If I take the union of B there, Q0, Q1, it becomes the Q0, Q1. Q1, Q2. So already this one included, this one included, this one included. So this is new state. Again, you have to go for the combination of these things. So if you go for the combination of this thing, you can see this type of things will become. After that, if you take the union, this figure will become, this will become. So this is simple process from the transition table, take the union of these two and calculate the value there. Okay, so if you go, we can get the result in this way there. Why here it will be stopped? We can see all the state of this part, all the state of this part is already present in this table. How you can see Q0 present here, Q0, Q1 present in this part, Q0, Q1, Q2 present in this part. It is already said that it is present here. Now the Q0, Q1, Q2, Q3 present in this part. Q0, Q1, Q3 present in this part. Q0, Q1, Q2 present in this one. Q0, Q1, Q2 already present in this part. Okay. And then these are the your this is the already present here and this is already present. So all the states are present here. There is no new state is left in this part there. If it is left, again you have to calculate. But here I can see that, you can also see that there is no left part is there. So we can stop here, and after stopping, we can say this is the your. And again, as I told that, you have to give the name of this one A, B, C, D, and E. Similarly, you can give the name of here, like it become the B, it become the A. In this way, we have to continue the things and okay. So thank you, my dear students. So what we have learned in this class is, in this class we learned that how we can go for the conversion of the non-deterministic automata into the deterministic one. First, find the initial state, see that where new state is available, take the new state in the left hand side of the table and try to find that whether new state is available. This process is continue until and unless whatever the right hand side new states are available, that will be present in the left. So thank you.